and welcome back. This is question 3 of the June 2012 paper C3, and we're going to start with part A. And we're given a graph here in figure 1, and it says that figure 1 shows a sketch of the curve which has this equation: y equals e to the x times root 3 times sine 3x, and it's given us the domain of the curve. And it's asked us to find the x coordinate of the turning point P on C, for which x is greater than 0. That's important. And give your answer as a multiple of pi. Now, with all turning points questions, we're going to have to differentiate, because we know that at a turning point the gradient of the tangent is 0. And if we're going to have to differentiate this, we're going to have to use the product rule, as it is one term times by another. And I'm going to say that u equal x root 3, and let v equals sine 3x, and we know that if we differentiate u with respect to x, we're going to get root 3 times e to the x root 3, aren't we? Because with an exponential term, all we need to do is bring the power down, but the power stays the same, because if you differentiate e to the kx, you just get you get k e to the kx. Differentiating sine will give us a cosine term. We also need to differentiate this term here, the 3x, and we get 3 cosine 3x. And now we're going to use the product rule. And the product rule states that dy dx equals v times the differential of u with respect to x plus u times the differential of v with respect to x. Right. So if we plug those values in, we get that dy dx equals sine 3x times root 3, which is times e, to put a times sign there to make sure it's not confusing, e to the x root 3 plus e to the x root 3 times the 3 cosine 3x. And what we can do is we can tidy that up a little. We can take e to the x root 3 outside, and we can just put here sine of 3x times root 3. It's probably better if I wrote that the other way around, but never mind. Plus 3 cosine 3x. And what we know is that we can forget equating that to dy dx. We know that this is going to equal 0. That means that either e to the x root 3 equals 0, or sine, or this part inside the bracket equals 0. And we know that e to the x root 3 cannot equal 0. Because even if you put x equaling to 0, you would get 1. So, and also, even if that's not right, we know that this is our domain, and we have to give our answer in multiples of pi. And what is the chance that this term, that x is going to be in terms of pi? So we say that sine root 3 sine of 3x equals minus 3 cos 3x. And what I've done, I've just skipped a stage there. I've decided to just make this bit of the bracket equals 0 and minus this term to the other side. And we can rearrange that to get root 3 tan 3x equals minus 3. And that's because we know that if we divide through by cos 3x, we're going to get sine over cos, which we know to be tan. If we divide by root 3, we get that tan 3x equals minus 3 over root 3. And if you just put that into your calculator, you get minus root 3. So we'll just write that there, minus root 3. If we inverse tan that answer, making sure that the calculator is in a radian mode, we get this answer here. We get that 3x equals minus 1/3 pi. But, as I said before, x has to be greater than 0. And we know that if we look at the graph, p, for p, the x has a positive value. So we need to find other values of 3x that will satisfy the equation. And what I use is the cast rule, or the quadrant rule, and I draw in my angle. Here's my angle, and I know it is minus pi over 3. But there's also another angle, isn't there, that's going to, because for tan, we're going to get positive values in this quadrant, positive values in this quadrant, but in these two, we're going to get negative values. And we're going to get an angle here of minus pi over 3, which will also satisfy the equation. But we don't want that angle there, we want the angle from 0 because we want a positive value. So the angle we actually want is this one here. And what is that angle there going to be? It's going to be 3x will equal pi, because if we go all the way around it's 2 pi, so if we go halfway around it's 180, or pi, minus the pi over 3. We tidy that up and we get 3x equals 2 over 3 pi, or at p, x coord equals 2 over 9 pi. There you have it. Thank you for watching, and join us for part 2.